polynomial graphs and equations. And today I'm going to post your hand in on as well. It's going to be due for Friday because we're going to go through it Friday class. And your test is on the Wednesday when you come back. So say I give you y equals 3x plus 4x to the negative 1. Polynomial equations are ones where it's like x squared, x cubed, x4, right? They just nicely roll, correct? X to the negative 1 is actually the same as saying 3x plus 4 over x, because you can make the x the one positive by moving it to the denominator. It's not a polynomial. So you cannot have negative exponents. What if I give you y equals 3x squared plus 2 root x? Root x is actually the same from grade 10 as x to the exponent this one has is a 1. What's in my index? What's above my radical if there's no number on this middle spot? A 2, right? If not, there's a number. We agree? If it's a cube root, it has a 3. If it's the fourth root, it has a 4. If it's the fifth root, it has a 5. If there's no number up there, it's a 2. You agree? In grade 10, we were taught how to make radicals into fractional exponents. So we had a 2, we had a 1. We just dropped that underneath, and it gave us x to the half. So if it was the cube root of x squared, that would give us x to the what? Take your 2, drop your exponent, your radical index underneath, and you get a 3. So it'd be the same as x to the 2/3. We agree? You've had a whole lesson on this in grade 10. Fun times. But it was really hard. Wish you could go back, I'm sure. Okay? So if this is the square root of x to the 1, this would be the same as x to the half. You can't have fraction exponents. This is not a polynomial. If I give you this, an x in the exponent is an exponential function. So you can't have variable exponents. So what can you have? You can have whole number exponents. To make a polynomial. What are whole numbers? What's the first number with a whole? 0. So whole numbers start at 0 and keep going. 0, 1, 2, 3, 4. Now some people will say, well, x to the 0, we never see that. X to the 0 is a constant number. So if you had y equals 3x squared plus 2x plus 7, Remember I told you have to make sure you can count down? So you'd go 2, 1. What is this one actually? X to the 0. Because x to the 0 is just what? What's anything to the power of 0? 1. So that's why we don't write it. But it is x to the 0 because you'd multiply by 1. Right? So some people don't think this is a polynomial. Y equals 4. It's a horizontal line at 4, correct? So the graph would look like this. What is it? X to the what? 0. Am I allowed to have an x to the 0? Yep, this is a polynomial. It's just a constant function is what it's called. We don't look at them into great detail, but I just want you to know that if you do get y equals 4, that is a, to the x to the 0, it is a constant. It is a function, and it is a polynomial. So let's look at the other ones that we looked at. So the first one we're going to look at, the first 3 we're going to look at are all the odd function polynomials. So ones with odd degrees. So we'll make ourselves a column. We'll go degree 1. We'll go degree 3. And we'll go degree 5. And we lump them together because they all follow the same deal. Because their arrows are both in opposite directions, right? At all times. That's just what happens in between that makes it a degree 1, 2, degree 1, or 3, or 5. So degree 1 functions are linear. You get y equals mx plus b, right? We did those in grade 9, 10. Degree 3 are called cubic. We started them this year. It's y equals ax cubed plus bx squared plus cx plus d. Do I need all of the values in between to make it cubic? Or could I just have an ax cubed? I could literally just have an x cubed and it's cubic. This is quintic. Y equals ax5 plus bx4 plus cx3 plus dx squared plus ex plus f. That's if every term existed. We don't need every term, right? We need every term with zeros for placeholders when we do synthetic division, but you don't need every term in order for it to be quintic. So a degree 1 function, it can look like this, or like this. And you could have wrote, instead of mx plus b, you could have wrote ax plus b, right? It doesn't matter what those variables are. When the equations are in standard form, which means they have no brackets, so none of these have brackets. No amount of stretching that length. So when they have no brackets, your constant at the back is your y-intercept. If you have your phone out, you shouldn't. Okay. So this is your y-intercept. If they say constant, that's another word for y-intercept. Just like if it said is a factor, they're telling you the remainder is 0, right? If you read is a factor anywhere in any question, they're telling you the remainder is 0. If they say constant, they're telling you the y-intercept. Okay? So you tell me, in this case up here, the red case, is my b greater than 0 or is my b less than 0? It's greater. Why? It's greater because the y-intercept's above the x-axis, so I have a positive y-intercept. Do I need any numbers in order to tell this? No. Could they give me all variables on the unit test question or on my diploma? Absolutely. You need to know that the constant stands for the y-intercept. So this black graph, what's my b value, my constant? Remember the constant, the one without a variable? This one would be b is less than 0. Could it have been b is greater than 0? Yes, if I put the line up further up here. It could still be downward sloped, but I could have a b greater than 0 instead, right? So the b is just where it is, my y-intercept. Okay. Now, this is something to pay close attention to. So the constant, no matter if it's degree 1, 2, 3, 4, or 5, tells me my y-intercept. That's a great thing. Doesn't matter if it's an odd degree function or an even degree function. The constant gives me my y-intercept. If the equation has no brackets, if the equation has brackets or it's in factored form, that's out. Okay? So none of these have brackets. But my leading coefficient tells how it ends on the right. The leading coefficient means number in front of a variable. Leading means the one that leads the equation. So the one in front of the biggest exponent is your leading coefficient. My leading coefficient tells me how I end on the right. So we can do that as a little statement. Leading coefficient determines how the graphs end on the right. What's awesome? That also doesn't change whether it's even or odd degree. The catch with odd, though, is that the arms are in opposite directions. We agree? So, my leading coefficient in this case is m. Could I have labeled it ax plus b? Yes. Could I have labeled it smiley face x plus b? Sure. It's just whatever's in front of my leading degree. So this one's x1 is my largest one, right? So this graph ends up on the right. So my m is greater than 0. My leading coefficient is greater than 0. LC for leading coefficient. And if I know my leading coefficient is greater than 0, I end up on the right. Because it's an odd function, I then end down on the left, right? All odd functions will end in opposite directions, always, remember? So this one, I end down on the right. So my m is going to be less than 0. We agree? Let's look at some examples before we even graph this. Say I give you y equals negative 3x plus 4. What can you tell me about this graph? My y-intercept, someone said? I heard them. What's my y-intercept? 4. So 0 and 4, right? Because in order for it to be a y-intercept, my x has to be 0. Where did you get that from? The constant. The constant, so is my y-intercept. And where does my end? Up on the right, down on the right? Down on right. Why? Because my leading coefficient is negative. My leading coefficient is less than 0. In order to stay in, instead of saying negative, they'll often say less than 0, because that's the same thing as negative. So let's type it into our calculators. So negative 3x plus 4. Ah, it's down on the right. I have a y-intercept of 4, which means it's also up on the left. Yeah? So nothing crazy. So let's do one more example. What if I give you y equals 2x plus 6? What can you tell me? It's up on the, because I have a positive 2, correct? And that's my leading coefficient, which means it's indirectly down on the left. Why? What kind of function is this? Odd. It's degree 1. And what's my y-intercept? 0, 6. Okay. So what could they do on the diploma? This is the equation in the form y equals ax plus b. Determine the value of a and b. And they give you multiple choice answers. Part A. A is greater than 0, b is greater than 0. B, a is greater than 0, b is less than 0. C, a is less than 0, b is greater than 0. D, a is less than 0, b is less than 0. Every option, right? Really easy to make multiple choice answers. Which one's right? I know b is less than 0 because my y-intercept is negative. Do I even have to actually give you a scale of what this graph is? No. Do I have to tell you what the numbers are or ticks at all? No. It's negative y-intercept, so I know I have a b is less than 0. And I'm down on the right, so I know a is less than 0. Really easy question if you know what they stand for, right? Ridiculously overwhelming if you have no numbers and nothing. Could you indirectly test these out? Could you put a positive a in and a positive b and see if it kind of looks like that graph? Yeah, if they give you variables, you can plug stuff in, right? You're not stuck just because they don't give you numbers. All right. Now, how many x-intercepts does a linear graph possibly have? Number of x-intercepts. 1. Can I have 0? Arrows in opposite directions. Can I ever have 0? No, it's going to cross somewhere. So all odd degree functions have arrows in opposite directions. So are they ever going to have no x-intercepts? Nope. So number of x-intercepts, this one has 1. Always. Because you max out at the degree of your function, which is 1, and you can't have 0 because the arrows are in opposite directions. Right? What's my domain and range? And arrows are in opposite directions. They're going on forever to negative x's and positive x's, right? Negative x's and positive x's? Yeah. Right. And then my range, right, because they're going on forever up here and they're going on forever down at the bottom. Except for if they're word problems, odd degree functions will always be, I need to put interval notation too. Interval notation is negative infinity, positive infinity. So this is set notation, the set of. This is interval notation. What if you do set notation, but you only write part of this because you don't care to write the whole thing, and it's a written response for the diploma? Nope. What if they say in set notation and you give them interval notation? Nope. You need to do what they say, and you need to do it full if you want full marks. The range is going to be y such that y is an element of the reals, except for if it's a word problem. And why do I say that? Say it's a word problem and it's a cost function, and say that it just increases as you go along, right? Now, say x is time. Can we have negative time? No. So then your domain would start at 0, okay? So if it's word problems, you have to see, does it actually make sense? Just because it's a degree 1 function doesn't mean it's XER, YER. Now, if it's a degree 1 function and it's not a word problem, it's always XER, YER. Life is good. It's only if it's a word problem that it could restrict the domain. Okay? So not too bad. We agree? So cubic is a degree 1 function with an extra bubble. Literally, that's all it is. Does a linear line have any maxes or mins? No, it's a line, right? So no maxes or mins. Degree 3, that can change. So we could go no max min. Okay? Degree 3. These will be really easy if you just remember what we did here. Follows the exact same things. So say I give you this. What's my leading coefficient of this particular graph? How do I end on the right? Up. So my a is greater than 0. Same rule, just has an extra bump. And if it ends up on the right, it ends down on the left because they're in opposite directions, because it's a what kind of function? Odd. And what's my d in this case? My d is my constant. My constant is always my what? Y-intercept, so what is it? Positive, which is greater than 0. Yeah. Do they always have to be both greater than 0? No, I could have had the y-intercept down here in the negatives too. Down on the right, what's my a value? Less than 0. And indirectly then, I'm up on the left because it's an odd degree function, they're an opposite. And then my d value is less than 0 because it's my constant, and my constant is my y-intercept, and my y-intercept is negative. My example. I don't have an x squared, I don't have an x, but it's still cubic, correct? You tell me, do I end up or down on the right? Down, why? Because my leading coefficient is less than 0, it's negative, so I end down on right. What's my y-intercept? Why? My y-intercept is 0 and 7 because my constant is just my y-intercept. I want you to answer this. For this example, the one in black I just wrote. Do I end up or down on the right? And what's my y-intercept? Answer that. Do I end up or down on the right? Up or down on the right? Up. When I put a fraction, people are like, oh goodness, what does a fraction do? Don't really care. I just care about the sign. I actually don't even care what the number is in order to tell me if it's up or down, right? It's a positive half, so it ends up on the right. Okay, then I did my other trick. What's my y-intercept? 0, because what's my constant? 0. I don't have a constant. Some people say 1. If it was a 1, I'd have a plus 1, right? So if I have nothing, my constant is 0. That just means I have a y-intercept at 0, 0, which means I also have an x-intercept there. What's my number of x-intercepts? Let's start at the lowest. Can I have no x-intercepts? No, because my arrows are in opposite direction. So at minimum, I have to have at least 1. So I could have 1. Could I have 2? Yep. Now this would have 1 x-intercept here. How many would be here? 1, but how many of that 1? I'd actually have 2. So remember when we got 2 factors and it was a multiplicity, so I got 2 factors, like say it was x minus 3 squared. We agree? It was x minus 3 squared. We said we had x equals 3 multiplicity 2, because we had 2 there. This is when you have 2. It's called the point of tangency. You have at least 2 there. It hits it, and then it bounces it back up. So this is only 2 x-intercepts that are different. This one just happens to have 2 at that spot. that are the exact same. They're both 3. So if when I said x equals 3 multiplicity 2, I'd get this bump. That's what happens when you have 2. It's called the point of tangency. So this is 2 x-intercepts. I have one here, 2 different x-intercepts, and one here. I technically have 2 that are the exact same there. And then I could have 3. Or it just passes through it all. What's my domain and range? Domain and range of odd functions that are not word problems are the easiest things on the planet. When you have arrows going in opposite directions, your x's are going on forever, and your y's are going on forever. So it's just XER, YER. So set notation is XER. Interval notation, negative infinity, positive infinity. Set notation YER. Interval notation, negative infinity, positive infinity. And now these can have max or mins. They're either going to have a max and a min, or a point of inflection. Yep. You say 2. It has 2 different x-intercepts. That's what they're always looking for. How many different x-intercepts does it have? If you were explaining it, though, you would say, if you were explaining what the x-intercepts are, you'd say like x equals negative 3 and x equals 3 multiplicity 2. That's the only way you tell them that there's actually 2 of the exact same x-intercept there. So we can have a max or a min. This is my max. This is my min. Or with cubics, we can have a point of inflection. What the heck does that mean? It means it's neither a max nor a min. It just looks like this. At this point, it inflects. So this is my point of inflection. There's neither a max nor a min there. It just changes. It just curves. So you can either have a max and a min, like the top one, or it just as a curve like that, which is called a point of inflection. An x cubed graph, just a basic x cubed graph, has a point of inflection, not a max or a min. What's the only thing that changes on a degree 5 graph? You can get an extra bump. You have 1 x-intercept or 2 x-intercepts or 3 x-intercepts or 4 x-intercepts or 5. You can't get 0. Your domain and range are still XER, YER, because your arrows are still going in opposite directions. Your leading coefficient still tells how it ends on the right. And on the left, it ends in the opposite direction. It's no different. You just get an extra bump. It literally just does this. So you get more max and mins. And therefore, you can get more x-intercepts, right? That's it. Domain is XER. Range is YER. X-intercepts, you start at 1 and you go to the max. 1, 2, 3, 4, or 5. You can't get 0 because arrows are in opposite directions, right? It's an odd function. Does that make sense? Even functions, there's only one thing that's harder about an even function. The range isn't YER. And you can get no x-intercepts. That's all that happens with an even function. Because remember, even functions are quadratics, or the ones that make W's or M's. So you actually have an ultimate max and an ultimate min. That would change your range. Your range isn't YER. So we'll go over those. But it follows all the same stuff. So say we do even degree functions. So you either have degree 2, which is quadratic, or degree 4, that's a Q, which is quartic. We only have to do degree 1 to 5. So is there more? Yes. Yeah. You just synthetic divide till the cows come home. It might be terrible. So luckily, we're limited to 5. But they can keep going on completely. They just follow the same pattern, right? All the odd degrees follow the same pattern. All the even degrees follow the same pattern. So if we look at a quadratic, you did these last year. You'd have y equals ax squared plus bx plus c. And remember, this only works because I have no brackets in my equation. My equation's in standard form, right? No brackets. So what can you tell me about my a value? How do I end on the right? I end up on the right, so it's greater than 0. Did that change whether it was odd or even? No. If it's up on the right, your leading coefficient's positive. If it's down on the right, your leading coefficient's negative. Doesn't matter if it's odd or even. What does change, though? Because it's even. It's up on the right, which is the same, but now it's also up on the left. Even degree functions end in the same direction. So odd degree functions, your arrows are in opposite directions, correct? Even degree functions end in the same direction. So if it's up on the right, it's going to be up on the left as well. So see, I'm up on this side too. Whereas odd functions, it would have ended down, right? And what's my c value? That's less than 0 because it's still just my y-intercept. It didn't change that this is even. Right? Nothing crazy. Quadratic, y equals ax4 plus bx3 plus cx squared plus dx plus e. It looks like that. Degree 2 makes parabolas. We've seen those before. Degree 4s makes m's or w's. Sometimes really wonky looking m's and w's, but m's and w's nonetheless. On the right, it is down. So what's my a? Less than 0. Doesn't change whether it's degree 1 or degree 2 or degree 3 or degree 4 or degree 5. The only thing that changes is I'm also down on the left because it's even, right? Even, you end in the same direction. Odd, you end in opposite directions. And what's my e this time? Because my y-intercept is negative. Could I have explained this lesson completely without numbers? Yes. So can they give you questions without numbers? Absolutely. Why would they do that? Because they're testing if you actually know what the heck you're doing rather than you're typing it into your calculator and looking where they are, right? You can type something into your calculator and actually know nothing about the graph. So they want to see if you actually know what you're talking about. All right. How many x-intercepts can I have for a quadratic? I could have 2. This is true. I could have 1. So you didn't know this last year, but I have 1 here, but how many do I actually have? I have 1 different one, but I actually have 2 occurring there. So you had an x-intercept at 3 multiplicity 2, right? So you only have one distinct x-intercept. It just happens to be happening twice. That's why you get that tangent spot. Or you could have none. And even degree functions, we can have none. Why? Yeah, because you can be completely above or completely below because our arrows are in the same direction, right? So the whole thing could be above and the whole thing can be below. It's not forcing it to cross through. Opposite direction arms, you're going to cross through at least once. But even, you don't have to. What's going to happen on a quadratic? You could have none. You could have 1. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . could have 2. You could have 3. Oh, that's going to be 4. Ignore that. You could have 4. You could have 3. Why is my 3 not working in my head right now? Help me. It's going to cause 4. How could I have 3? That would be 2. My goodness, why can't I get 3? Why is this blanking in my head right now? You can get 3. How could we get 3? Ah, yes. Thank you. 3. Oh my goodness, why was that not happening in my head? I'm like, I can't. I did do a 3 before, didn't I? Look at me. I did a 3 when I didn't think I did a 3. I'm so good. I'm not. That was really bad. 3. 4 is really easy. That was even boom, boom, boom. 4. Ha! I did a 3 and didn't even. It's like, why can't I do it? And then I did 1. That's skill, guys. Doing something you meant to do and didn't think you did it, and then you did it. Also confusing. Okay. I'm boiling. Anyone else? Yeah. All right. Domain. Still easy. What's my domain of a quadratic? Except if it's a word problem. XER, because the arrows are going all the way out in both opposite directions, or all the way out, down in both opposite directions. Every polynomial, unless it's a word problem, has a domain of XER. Same with this one. But my range of even degree functions is different. It's not YER, right? So remember, if you had a maximum last year, your graph is completely what? Less than that or greater than that? Less. So if it was downwards, you had y such that y is less than or equal to the max. And it's equal to the max because you don't have an open dot on your maximum, do you? It equals that number, and it's less than that number. The whole graph is either equal to that number or less than it. There's no graph above it, but there's graph below it. If it's a minimum, sorry. What's the only thing that changes? It's going to be y such that y is greater than or equal to the minimum. Now, if it's less than or equal to the maximum, it's going to be equal to the max, and then less than negative infinity, interval notation. If it's greater than or equal to the minimum, you have the minimum, and it's greater, so it's going to go to positive infinity. What's the easiest way to look at it? These little arms here represent negative infinity, do they not? So we're going from negative infinity to the max. These ones, I'm going from positive infinity to the min, but I always write low to high. It's going to be the exact same for quartic. You just need to find the absolute minimum. So I would have to use this value, or the absolute maximum. So I would have to find this one, right? Which only makes sense. Pardon? It keeps going up, but not down. Does that all make sense? if you can understand this without numbers, it's really easy when you get numbers. You can plug in your calculator and look at it for all it matters, right? But if you understand what it gives you when you don't have numbers, life is easier. So what happens if they do give you stuff? So say they give you determine a graph with an odd degree. B, a negative y-intercept. No, they wouldn't probably even say y-intercept because that's too nice. A negative constant, maybe they would. And leading coefficient. One, 0, with multiplicity 2. Written response. Why do you guys find this harder? Pardon? Yeah, you can't see anything. I gave you no numbers. It's completely open to interpretation, and every single one of you could draw me a different graph and be right. Okay? So let's break through this at the very least. What do we know? We know it's an odd degree. What the heck does that mean? Odd exponent on the x. What else does it mean? Arrows go different directions. Yeah. What else? It could be degree 1. It could be degree 2. It could be degree 3. I have 1, 0 with multiplicity 2. Is that possible to be degree 1? No. It doesn't say I have only 1, 0 with multiplicity 2. It just says I have a 0 with multiplicity 2. So I could have more. Right? Okay, so I know my arrows are in opposite directions. I know this has to be at least a degree 3 function. It can't be a degree 1 because I have more than one x-intercept. As a negative constant, what does that mean? I have a y-intercept that's below. So I'm just going to give myself 1. Boom. I have at least something drawn on this graph at this point. Could you draw it anywhere below? Absolutely. It has a negative leading coefficient. So where am I going to end? Down. So, sure. Which also means I do what? Start up somewhere. This is going to be the most beautiful drawn graph from 2 random arrows and random spots and a random y-intercept. Probably not. I may have to change those arrows a little bit. Okay? The only other thing they gave me is I have to have 1, 0. That basically makes a bump, right? Because it says multiplicity 2. So I need a 0, an x-intercept, that when I go to the x-axis, I make a bump. I am down on the right, and I have a downwards y-intercept. So maybe if I put a bump here, it at least will send me back through that, right? Then what could I do? Just go up. I'm done. No, a multiplicity of 2 means there's 2 there. So there has to be a bump somewhere on this graph. 2x, an x-intercept that occurred twice there. So if I give you this, y equals 3, x plus 1 squared, x minus 3. Uh-oh. There's brackets. Now I have to expand the whole thing out so there's no brackets. No. Different forms give you different things. The form without brackets gives you how it ends on the right, and it gives you your y-intercept. True? But does it give us our x-intercepts or anything? No, if we want our x-intercepts, we'd have to do synthetic division to get our x-intercepts, correct? With that long expanded form without any brackets. This form gives me my what really quickly? My factors. And my factors give me my what? X-intercepts really quickly. Both forms are good for different reasons. So this one, I have x-intercepts at -1 multiplicity and 3. I can also get my y-intercepts really easy. When you think y-intercept, you should instantly think what? X equals 0. That should be like, you think x-intercept, y equals 0. Y-intercept, x equals 0. You have to think that immediately, because that is what they're indirectly telling you on the diploma when they say y-intercept or x-intercept. Okay? So if I want my y-intercept, x equals 0. So I'll put zeros in for my x's. Some people will tell me it's -3, because that's a constant. Well, no, it's not the constant. The constant only happens when the whole thing's expanded, no brackets, right? Is this whole thing expanded, no brackets? No, so the only way I can get my y-intercept is by filling x equals 0. So I'm going to go 3, 0 plus 1 squared, 0 minus 3. And so I'm going to get y equals 3, 1 squared, which is 1, -3. What's my y-intercept at? -9. We agree? Now, why am I leading into this? Well, let's plot what we know. We know we have x-intercept at -1. We know we have 2 there. It's either going to bounce up or bounce down at -1. We agree? And we have an x-intercept at 3. And we have a y-intercept at what would be helpful right now? Do we need a leading coefficient in order to answer this question? No. Could we get a leading coefficient? Sure. But we don't need one to answer the question. It's a degree what function? It's a degree 3. This is x what? Squared when I'd expand it. When I'd expand it, I'd have an x plus 1 and an x plus 1 and an x minus 3. We agree? So when I would expand this, it would be an x times an x times an x, which is a x3. So I know it's an x3 graph. I know I have to end in opposite directions. My leading coefficient is really easy to find, actually, when it's expanded like this. You just multiply all your front numbers. 3 times 1 times 1 times 1. What's my leading coefficient? 3. Why can I just do that? Well, if you had a basic one like last year, 2x plus 1, say, and x plus 4, we would multiply these two, and it would get us 2x squared, which would be my leading coefficient, would it not? Same thing's going to happen here. If I multiply all the numbers in the front that are leading it, I'll get my leading coefficient of 3. So I know that this thing actually ends up. Does it bounce off of this one or bounce off of that one? It bounces off of this one because that's one with multiplicity 2. We agree? Now, I get this all the time. How could we more accurately draw this? Type it into our calculator and just actually sketch it from there, right? But if we didn't, say they had a letter in there and it knocked it off, you couldn't. This is what I get people doing. Just because there's a point here and a point here does not mean they directly connect weirdly like that. Remember, it's going to make something that's like an S shape of some sort. So you guys like go crazy and like connect them. Not going to happen. What's probably happening is I need to get a direct line from here to here somehow, right? So it's probably going down like this, then cutting through the y, coming up here, and then what to do when it hits this one? Up and down. Does that look more like an S kind of sideways shape than if I went directly to the y-intercept? Majority of the time, 99.8% of the time, you are not going to go from the x-intercept directly to the y. So don't do that. You guys do it all the time. It does not look like a good, accurately sketched graph. It's just going to make like a V of some sort randomly, and it's not rounding that doesn't make it less of a V. Weird shape. Okay? Your S is quite symmetrical too. So when you draw a sideways one, you should be able to almost draw a line through it, and it should kind of be symmetrical on both sides. So if you have something crazy like that, is not at all looking symmetrically the same on both sides. All right? Okay. So what we're going to do for the next little bit is we're going to work together on questions in our book. When we get stuck, we're going to ask Mrs. Lepp to come over and help us. Okay? And we're going to work together in partners, because sometimes people get stuck when it's on little things, but you won't be if you don't. And we're going to work.